Hello, and welcome to today's session. I'm Jeffrey Palermo, and I'm the Chief Architect of ClearMeasure, and we're a DevOps-Centered Software Engineering company serving the greater United States, focusing on Microsoft and cloud platforms. And over 2 decades of working with custom software, I've seen so many modernization projects, and I know the challenge that an aging system poses. And so today I'm going to show you a faster path to software modernization, regardless of which of the three major strategies that you choose. And I know how busy that you are on this call, and so my goal is to get you in and out of here as quick as possible, not take up a full hour. This should be quicker than that. And thank you for your time. I know you're all busy. Just judging from the attendee list here, we have a good swath of IT and software development leaders and executives who invariably have an existing system and you're looking forward to figuring out how to carry it forward, either have a good integration replacement or fixing it and preparing it for the next 10 years. So let's get right into it. And logistics wise, there is a Q&A panel in the software. And if you put in a question there, I will try to work it in to the content as we go along. But my commitment to you is that any questions that are still there, we won't close the webinar until all the questions are answered. So for today's agenda, we're going to talk about the challenge of aging software and why we find ourselves in need of a modernization. And then we'll explore some symptoms of an aging system. And then we'll look at the overall roadmap of how to plan your modernization, including available strategies, the details of each strategy, and then some value that we have provided to clients that we've helped through this process. And at the end, we'll share some ways that we could possibly assist you. All right, so here's the challenge, and I think you all know it well. You might call it your system, you might call it a legacy system, or you might call it something else, but a system that is showing its age is not resilient to change any longer. When it goes down or has stability issues, real business disruptions occur, and these systems are important. These systems are no longer able to change at the pace or in the way that's necessary for the organization to execute its go-forward strategy. And when the software starts holding your business back, you have to address it. And we all feel the pain. You change one thing in one part of the system and two things in a completely other part of the system break. And we all want low risk, high speed modernization. And in some cases, perhaps someone on this call just wants a modernization to be possible instead of just tiny band-aids and leaving it in place. So there's some symptoms that tend to be really common across the clients that we help, but they're just symptoms. They're just on the root cause. So let's dive into that problem a little bit. We have an aging system, a legacy system. It could be an old platform. Certainly COBOL mainframe systems are called legacy systems, but it doesn't have to be a platform that old. It may be just the symptom. Your team may call out the system and may say, hey, we just need to replace it. Your managers may be reporting problems retaining your developers or recruiting new ones. And the candidates themselves, the development candidates that you're looking to recruit, may be opting for other companies when they learn about the software system that they'd be working with. And finally, you might be experiencing instability. And again, if changing something breaks something in a completely unrelated part of the system, your staff starts to become fearful and hesitant to make changes. And so these are the symptoms, but there could be root causes lying under the surface. And the most common ones are at the bottom right here on this screen. And we'll go into them. Lack of maintenance, perceived lack of opportunity with your recruits. And then we also find the insufficient development environment is in place for the purpose of making changes. All right, let's dive into what the 3 strategies are. So the 3 strategies for modernizing an application are package replacement, rewrite, or fix and upgrade. Regardless of the shades of gray of each of these 3, these are the 3 possible strategies that you have. You're going to pick one. You're going to pick one or the other. Now, we'll ignore what is sometimes talked about as another strategy, which is not a strategy at all, which is to do nothing and wait out the problem. The problem will never go away. So doing nothing is not a strategy. But each of these 3 strategies on the screen have some benefits and drawbacks. The package option promises to be the quickest to a full replacement, and certainly the people selling the package are going to promise that, but it's still not quick, and it's certainly not cheap. I mean, we're talking about 7-figure budgets for any of these, right? The stakes are high here, but the package sellers, they're going to tout their faster timelines than a full custom rewrite. And in a lot of cases, they're right. If there is a package that is suitable, and when you built the system, build versus buy went in the favor of build. But if you were to do it all over again, there's better packages out there, and buy is a better. Certainly, there's better packages today than there were probably when the system was built, and that may cause you to choose that strategy. You could rewrite the system in a modern technology like C# or Azure. And that's the rewrite option. Or you could fix the problems that you're having with the system and fix the problems that have been plaguing you. Now, if you're considering this, then oftentimes the fix and upgrade scenario has kind of been fruitful, because you say, hey, we tried that. And that's real. That's a real struggle. So this 3rd strategy could seem far-fetched. You're looking at the first 2 strategies because your people, they have tried and tried to fix and upgrade things through the years, and you still find yourself with a system resistant to change. So these strategies, 1 or 2, they look very promising, but the duration that you have to wait until real usage is a problem. The duration to value is a problem. If you can't change your system, and here's the logic to help you choose which one. If you can't change your system, then you have to replace it with a risky cutover event down the road, 18 months to several years. That's problematic because your business just can't do nothing for 18 months. These are big, significant systems. So let's dive in a little more. Let's figure out how to see some value quicker. If we can segment the system to do some interim releases, then we can capture value quicker. And that's a better way to execute the same strategy. Okay, so with package replacement or rewrite, that's a way to get to the value portion quicker. But if we are going to have to release where some of the new and some of the old system are in place, because we've made that segmentation, we've integrated, and we only have the package implementation for some of the users or some of the features, or same thing with a rewrite, then we have to be able to change and refactor our existing system. So we realize that regardless of the modernization strategy that's right for our business, we have to regain some control over the system that we have. Otherwise, we are going to commission a long and expensive project and set up a highly risky big bang cutover event. And we all know that these types of projects love to fail. And I'm not here to sell you on a strategy. Any of these are viable. But I'm here to tell you that even though you have an aging legacy system that's hard to change, you have to do what's necessary to gain some control over it. And if you don't, you're sunk. All right, so let's talk about how to do that. It's more than just having a way to execute changes. And on the screen here, this change cycle probably looks familiar. And you all do some form or fashion of plan, code, integrate, package, release, operate, learn. And the cycle revolves around a capability to build and deploy the software, but it's woefully incomplete. And you probably all heard of DevOps. That's why you're coming to this webinar. And yes, we are going to talk about some things that's necessary for your existing system in order to enable you to go down any of the three paths that you choose for modernization. So to execute that modernization, we need to gain control over the system. We have a model for that, regardless of platform, whether COBOL or even just older .NET, or even if you have a poorly designed system that you inherited, you need to be able to change it. So the center is the foundational infrastructure necessary to make changes and redeploy them. But there are some other layers of capability that are needed as well, and you'll use these to regain control of that system and during the entire modernization as you make some fairly significant architectural changes. Okay. Now, for each of these layers, each of them has to have a sound strategy, be executed with discipline, and have objective measures. And we'll dive into that. So it starts in the center, but we made it a little black center, the automated DevOps pipeline. Now, before we move on, this is the basic structure of any automated DevOps pipeline. We just so happen to show Visual Studio Team Services, or the newly rebranded Azure DevOps Services, and Octopus Deploy, which is the most common combination that we see out there in the marketplace. And I know you can't read the text on the screen, but this is just 1/3 of a much larger, more detailed architectural poster of the way a automated DevOps pipeline needs to be put together, needs to be structured. If you would like a full-size PDF of this DevOps poster, then by all means, just put something in the chat or the Q&A, and we'd be happy to get you a high-res digital copy of that, and you can print it out at your print shop. I think it's Architecture D paper, or whichever is the 2-foot by 3-foot paper, and you can do that. But you absolutely have to have this DevOps infrastructure in order to just be able to move quickly. Not having a DevOps pipeline almost guarantees that it will a system will show its age as soon as the original developers leave the company, even if you're developing a new application. So we see some, and the link of the poster, we just put that because there were so many requests for it. We just put the link right there in the chat. If you need some help setting up continuous integration and automated deployments and feedback, like 3 tiers of test automation and static code analysis, just let us know. And by the way, you also need to automate the database, not just the front end of an application. Database changes are just as important. So let's dig into the various layers. We're going to go through these quickly because we've done other webinars that kind of deeper dive into this. But the first one is best practices. We're gonna talk about this specifically for a legacy system and what kinds of things you need to think about for a legacy system. But you need to determine what practices you're going to use. There's so many practices that have been labeled best that it's logistically impossible to use them all. But for a legacy system, there are some practices in particular and that are extra useful. One is feature branching, and that's making small changes and redeploying frequently because you don't want to stabilize, and that one helps you really make sure that a change is vetted before it gets put into the master branch. And with the DevOps pipeline, you have the ability to deploy a branch-based release candidate from a feature branch so that you can actually get it into the hands of people without having to change the main line. Another practice is refactoring. And refactoring is improving the structure of existing code without changing its behavior. And if we're going to segment anything, if we're going to integrate it with a package or with a replacement system, we're going to have to insert some architectural seams. So we're going to have to change some of the structure of the system without changing its behavior and be able to redeploy that. So refactoring is a practice we'll have to use. Another practice is continuous integration, and that is bringing together the changes of various people so that no single change is large. We can couple that with feature branches and make sure that we are making very, very small changes and rebuilding, redeploying, running whatever test suites we have, and building up test suites along the way. All right. So defect removal is another part of this model that we need to have a strategy for. Big changes during a modernization, that's going to happen, and you need to be able to find defects. And so we want to start with testing, but a lot of people think about unit testing, and that's a really good type of automated testing to start with when you are building a new application or doing enhancements. It's the wrong type of testing to start with when you have an existing legacy system with absolutely no tests. And so the progression of testing goes unit testing, component level integration testing, and then full system testing normally. And you want to have an order of magnitude that is 10 times as many unit tests as integration tests, 10 times as many integration tests as full system tests. But when you have no tests, you want to start reverse. You want to start with full system tests to cover large sections of the software. And these typically use UI drivers like Chrome. And most people have a legacy system that's a web application, and there's a lot of desktop applications out there, but Selenium is a very popular web browser driver for web application testing. And so it literally is a robot that can open up the browser, click on links, type things in text boxes, hit buttons, and do exactly what you would do from a manual regression testing standpoint. So you want to start with full system testing and cover your major transactions first. And that so that when you make a change and a normal function of the software just flat out breaks, your DevOps environment basically brings that to light on the feature branch before it ever gets to an actual user. And so covering tests using a full system testing style is gonna be really useful here. Next is formal recorded regression tests with Azure test plans. And with Azure DevOps services, you can, from a manual testing perspective, have your group that does manual testing screen record every testing session, and keep records, and they're automated in that way. And that way, when something doesn't break, you can have a faster cycle when getting information from a bug report, because you can actually see what happened. And then another practice in defect removal is the definition of done. With each change, with each refactoring, covering tests, these full system covering tests need to be run. That needs to be part of the definition of done. And then other checks that are specific to your software, that keeps you safe, and that needs to be a part of your definition of done. So every time you make a change, there should be a checklist of what it means to be finished with that change and agree to it as a team. The next layer is team workflow. So we want to get back in control of your system. If everyone seems to be using a Kanban board, whether it's Jira or whether it's Azure Boards or any other project management system, it is a Kanban board with columns and cards move across from left to right. So when we're going into a modernization project, we need to add extra columns to the Kanban board just to call out where we are in a particular change. One of the columns you are going to want to add is literally, quote, understand user scenarios. Because if you were not the original developer, or if you haven't become the absolute power user, then you don't understand every user scenario. And so if we're going to change part of the system, we need to make sure we do that. Another column you're going to want to add is add covering tests. And these are these full system tests to keep you safe before the code starts changing. And so these are extra things that are necessary, and it makes sense to call them out as stages so that you have better reporting, and you can say, you know what, we are not yet in development for this particular change because we're still cataloging and understanding the user scenarios that could be impacted by this particular change. And that way it helps everyone know what's going on. Because if we have insufficient reporting, then everyone else is just going to be asking all kinds of questions because they're seeking to understand what the status is. That's normal. And if you had staff turnover, your people, they're not the expert power users. You need to solve those knowledge gaps. Okay. Next layer is architecture blueprints. Now, in our other webinars, we talk about the 4+1 view model of software architecture. And in 1995, Philippe Khrushchev, he was at Rational Software Corporation at the time, he wrote a white paper on probably to this day the best iterative and emergent architecture model that's still out there. And it's the 4+1 view model of software architecture. You could do an internet search for it. It's a PDF. You want to make sure that you understand the shape of the system that you have, and you want to update that architecture. The 4 is the 4 layers, the minimum 4 layers. You want to have the 4 layers are the physical, or in this day and age, the runtime layer. What's the shape of the environments that it's running on in production? Next layer is logical. What are the logical components of the software and the dependencies between them? Next layer is the process layer. What is the order or sequence of data as data flows through your system, the path of major transactions? And then the 4th layer is the development environment. What is the shape of the necessary development environment necessary to modify this system? And development environment is synonymous with the DevOps environment. What do we equip the engineering team with to be able to maintain change and grow this system? And so we want to know what the shape of the system is currently. Otherwise, every person's going to have just a different level of understanding, different image in our own brains. And also, as the leader of the team, you need to cast a to-be vision, a end state vision for what the system will look like when finished. And then also, you need to draft transitional architectural states at each milestone so that everyone understands what the shape of the system should be with each major transition. Use this to align the team and to inspect what's changing. And one replacement pattern is the quote strangler pattern. And that pattern is whereby you refactor parts of the system to disconnect them or to take them offline. And if you're choosing that second strategy, the replacement strategy, and then once it's disconnected, once that code is dormant, you just leave the code in there dormant. And that sometimes can be less turbulent than attempting to extract and delete the code if it causes the structure of the system to start to crumble. So strategically, you're defining what is changing, okay? And what the system is going to look like at every transitional stage, and aligning your whole team. That's really important. All right, the next layer is cloud operations. So you want to assess the state of your logs and observability characteristics. Are you able to see exactly what's going on? And if not, add more telemetry. Provision a centralized log and analysis environment. Make sure that every bit of logging, metrics, events coming from the system running in production or any environment is funneled to a centralized database of some type that can be queried so that you can see what's going on. And as you make each refactoring and as you make each transitional state, you compare how the system is behaving and validate the theories that you're executing on. And then for operations, you want to recreate an environment. Some of you probably have a legacy system where it's been running on the same servers for a long time, and you've tried to stand up new servers and install the system again, and then you kind of backed off. But you need to prove to yourself that you can recreate a production environment. And if you can't, you are one step away from an outage turning into a disaster. And it'll also force the learning required to automate environment recreation in your DevOps pipeline. So again, our goal is to regain control over our system so that we can make the needed changes as we move along our chosen modernization strategy. So the perceived easy way out of a legacy system that your team is fearful of is to avoid it, to just not do anything. And then if you've gotten budget approval to replace it, build something up next to it, and then just cut over to the new system. but that is the riskiest project you can do, is these big bang cutovers. Actually, whether or not it's a package or a custom replacement, a big bang cutover is the riskiest project that you could take on. And it's, everyone's energized for the first few months because it's a greenfield system. It's a new system. But, Fred Brooks, in his Mythical Man Month book of essays, has one essay called The Second System Effect. And it kind of catalogs, going back to 1959, how the second version of a major system, essentially the replacement, it just tends to fail. And so read that essay, because it's a super risky project. So you have a legacy system, you see the storm clouds, the lightning, but facing the storm can often get you through it quickly. Let me give you a story of the buffalo on the plains of the western U.S. So cows and buffalo tend to be a little bit different. On the plains, storms tend to come from the west and then they move east. Herds of cattle, tend to see the storm and then they start to just walk away from the storm. They start to avoid it. And so they start walking east. The buffalo see the storm and they start walking west into the storm. Now, what ends up happening is the cows, they start walking east and eventually they get to the edge of the ranch, the barbed wire, and they can't go any further. The storm kind of overtakes them along the way and it goes over. The buffalo, they start walking west. They get to the storm faster, but the buffalo get through the storm quicker than the cows because the cows are moving with the storm. So they stay in the storm longer. So be the buffalo, face the storm. We've got some examples of success stories that we've helped through. You can see more of those on our website. I won't go through these here, but our clients tend to be pretty significant companies that haven't always thought of themselves as technology companies. They're not selling technology, but they've realized that over the years they've had to develop something for themselves, and so they have some significant legacy software. And they're looking for the path forward. And so whether it's helping to choose the right strategy or helping to execute the strategy or regain control, we love helping out our clients. And so one easy way to get some help from us is to even do some architectural level advisement. We can help you pick a modernization strategy. We can help you put in place a DevOps environment for your legacy system so that you can regain some control over changing it and shortening the change cycle for that system. And we're happy to help, even if it's just answering some questions. Happy to help do that. And so this is my direct contact information. If you'd like to give me a call and ask a question, I do that all the time and happy to do so. My Twitter is also here and my email address on the screen. And actually, there is a new resource that we have, and I'll hold it up. It is a new book called .NET DevOps for Azure. And the preview edition is here in my hands. It's working its way up to Amazon.com, but you can, just for being on this webinar, if you'd like, you can request a free ebook copy. We'd be happy to get that to your team, a free electronic copy of this. And you can go to bit.ly/.NET DevOps book, and you can download a hard copy preview edition. Just go to my Twitter account. The links are all over it. And also take advantage of that. All right. So I believe that I've answered the questions that were posed in line during the webinar. So thank you for those. And I know your time is valuable. I'm glad that I was able to hit the 30-minute mark and get you in and out. If you have any other questions that you think of later that you were not able to put into the Q&A window, then go ahead and just send me an email. I'll be happy to answer those. The ebook link, if you like that, it has just been put into the chat. And I thank you very, very much for your time. This is always fun for me to share this information, and good luck with your modernization journey.